Information technology, commonly known as IT, forms the backbone of modern business operations. It encompasses the entire spectrum of computing technology used for creating, storing, processing, and exchanging electronic data. Think of servers, networks, software applications, and databases. IT departments traditionally focus on managing data flows, ensuring cybersecurity for enterprise systems, and supporting business processes like finance, human resources, and customer relationship management. Their primary concerns revolve around data integrity, availability, and confidentiality. The smooth functioning of these systems is crucial for decision-making, communication, and overall organizational efficiency, making IT an indispensable component of any contemporary enterprise striving for success. The historical separation between information technology, or IT, and operational technology, or OT, was not accidental but a product of their distinct evolutionary paths and core functions. It evolved from early data processing systems, primarily focused on business administration, accounting, and communications. Its development was driven by advancements in computing power, software development, and networking protocols designed for office environments. The primary concern was managing information. This led to a culture centered around data management, updates, and relatively frequent changes to systems to improve business efficiency and adapt to new software versions. The workforce in IT typically comprised computer scientists, software engineers, and network administrators. Operational technology, conversely, grew out of industrial automation and process control. Its roots lie in electromechanical relays, pneumatic controls, and later, specialized digital controllers designed for harsh industrial environments. OT systems were built for longevity, reliability, and deterministic performance, often operating with proprietary protocols and minimal external connectivity. The focus was on controlling physical processes with high precision and ensuring safety. Changes to OT systems were infrequent and meticulously planned, as any disruption could halt production or compromise safety. The OT workforce traditionally consisted of engineers with expertise in specific industrial processes, instrumentation, and control systems. This divergence in origins fostered different priorities and risk perceptions. IT valued agility, scalability, and the adoption of new technologies to enhance business capabilities. Security in IT often meant protecting data from unauthorized access or cyber threats. OT, however, prioritized stability, predictability, and physical safety. Security in OT was primarily about preventing unauthorized physical access or operational errors that could lead to equipment damage or accidents. The concept of Patch Tuesday, common in IT, where systems are regularly updated, was anathema in many OT environments where uptime was measured in years, and any change introduced a potential risk to continuous operation. Furthermore, the vendors and ecosystems supporting IT and OT were largely separate. IT vendors focused on enterprise software, networking equipment, and personal computing devices. OT vendors specialized in industrial control hardware, SCADA software, and sensors tailored for specific industrial applications. This resulted in different standards, communication protocols, and skill sets, reinforcing the divide. IT professionals often lacked understanding of industrial processes, while OT professionals were less familiar with enterprise networking or cybersecurity best practices common in the IT world. This chasm created inefficiencies and missed opportunities for holistic operational improvements, a situation that modern advancements are now compelling businesses to address. The convergence of information technology, or IT, and operational technology, or OT, is no longer a futuristic concept, but a pressing business imperative. The primary driver for this union is the immense value that can be unlocked by integrating data from physical operations with enterprise business systems. In today's competitive landscape, businesses need real-time insights into their entire value chain, from the factory floor to the customer. Siloed data prevents this holistic view, leading to suboptimal decisions, inefficiencies, and missed opportunities for innovation. By bringing IT and OT together, organizations can gain unprecedented visibility and control over their operations, enabling more agile and informed decision-making processes. One of the most significant reasons for convergence is the pursuit of enhanced operational efficiency. When OT systems, which generate vast amounts of data about machine performance, energy consumption, and production output, are connected to IT systems, this data can be analyzed to identify bottlenecks, predict maintenance needs, and optimize processes. For example, data from sensors on a production line, OT, can be fed into an enterprise resource planning, ERP, system, IT, to provide real-time inventory updates and adjust production schedules dynamically. This integration minimizes waste, reduces downtime, and improves overall equipment effectiveness, OEE, leading directly to cost savings and increased productivity for the entire organization. Furthermore, the convergence facilitates better risk management and improved safety. Integrating OT security data with IT security operations centers, SOCs, allows for a more comprehensive view of potential threats that could impact both physical and digital assets. As OT systems become more connected, they also become more vulnerable to cyber attacks. A converged approach enables the application of robust IT cybersecurity practices to the OT environment, tailored to its specific needs, thus protecting critical infrastructure from disruptions that could have severe safety, environmental, or financial consequences. This unified security posture is essential in an era of increasing cyber threats targeting industrial systems. The importance of IT-IoT convergence also lies in its ability to foster innovation and enable new business models. Access to integrated operational and business data can spur the development of new products, services, and customer experiences. For instance, manufacturers can use data from connected products to offer predictive maintenance services or usage-based pricing. Utilities can optimize energy distribution based on real-time demand and supply data. This data-driven innovation is crucial for maintaining a competitive edge and adapting to rapidly changing market demands. Ultimately, the convergence is about transforming businesses to be more intelligent, responsive, and resilient in a deeply interconnected world. The Internet of Things, IoT, has emerged as a powerful catalyst accelerating the convergence of information technology, IT, and operational technology, OT. IoT refers to the network of physical objects, devices, vehicles, buildings, and other items embedded with sensors, software, and connectivity, which enables these objects to collect and exchange data. In the industrial context, often termed the Industrial Internet of Things, IEOT, these things are machines, sensors, actuators, and other industrial equipment. IoT technology provides the essential infrastructure and tools to bridge the historical gap between the physical world of OT and the data-centric world of IT, making seamless integration more feasible than ever before. IoT devices generate a massive volume of data from the operational environment. Sensors can monitor everything from temperature and pressure in a chemical process to vibration in a motor or the location of assets in a supply chain. This granular real-time data, which was previously isolated within OT systems or not collected at all, can now be transmitted, stored, and analyzed using IT infrastructure, including cloud platforms and big data analytics tools. This capability allows businesses to gain deeper insights into their operational performance, identify inefficiencies, and predict potential failures with greater accuracy. The ability of IoT to collect and transmit this data effectively is a cornerstone of successful IT-IoT integration. Moreover, IoT facilitates enhanced control and automation by enabling bidirectional communication between IT systems and OT devices. For example, an IT-based analytics platform might analyze data from various OT sensors and then send commands back to OT systems to adjust machine settings for optimal performance or to initiate a maintenance work order automatically. This closed-loop control, orchestrated across both IT and OT domains, leads to more responsive and adaptive operations. The development of standardized communication protocols within the IoT ecosystem, such as MQTT and OPC UA further simplifies the process of connecting diverse devices and systems from different vendors, a significant hurdle in the past. The role of IoT extends beyond mere data collection and control. It fosters a new paradigm where physical assets become intelligent, connected components of a larger digital ecosystem. This allows for the creation of digital twins, virtual replicas of physical assets or processes that can be used for simulation, analysis, and optimization without impacting real-world operations. By leveraging IoT to connect the physical, OT, with the digital, IT, organizations can unlock new levels of efficiency, develop innovative services, and create smarter, more resilient operational environments. IoT is therefore not just a technology, but a fundamental enabler, transforming how IT and OT interact and create value together. Section 5. Bridging the cultural chasm, people, priorities, and perspectives. One of the most significant yet often underestimated challenges in achieving successful IT and OT convergence lies in bridging the cultural chasm between the two domains. For decades, IT and OT professionals have operated in distinct worlds, fostering different mindsets, priorities, and ways of working. IT teams are typically accustomed to rapid technological changes, frequent updates, and a focus on data confidentiality, integrity, and availability for business users. Their world is one of software versions, network speeds, and cybersecurity threats. They are often driven by innovation and the need to support evolving business requirements, leading to a culture that embraces change and iterative development. Conversely, OT professionals have traditionally prioritized system stability, reliability, and, above all, safety. Their systems control physical processes where failure can lead to production halts, equipment damage, or even loss of life. Consequently, the OT culture is often more conservative, risk-averse, and resistant to changes that haven't been thoroughly vetted over long periods. If it ain't broke, don't fix it has often been the prevailing mantra. Their expertise lies in engineering, industrial processes, and the specific machinery they manage. They may view IT-driven changes such as network segmentation or software patching with suspicion if not properly contextualized to their operational realities. These differing priorities can lead to significant friction during convergence projects. For instance, IT's desire for standardized platforms and regular security patching can clash with OT's need for validated systems that may run on older proprietary technology to ensure uninterrupted operation. It might see an unpatched OT system as a severe security risk, while OT might see the patching process itself as a greater risk to operational stability. Communication styles and technical jargon also differ, leading to misunderstandings and a lack of mutual appreciation for each other's constraints and expertise. Without addressing these cultural differences, technological solutions alone will not suffice for successful integration. Successfully bridging this cultural divide requires strong leadership, clear communication, and a concerted effort to foster mutual understanding and respect. Cross-functional teams, joint training programs, and the development of shared goals and metrics can help break down silos. IT professionals need to understand the critical nature of OT systems and the potential consequences of disruption, while OT professionals need to appreciate the benefits of modern IT practices, particularly in cybersecurity and data analytics. Creating a unified vision where both IT and OT contribute their unique strengths towards common business objectives is paramount for navigating the human element of convergence. Section 6. Navigating the technical maze: integration challenges and solutions. Beyond cultural differences, the convergence of IT and OT presents a host of intricate technical challenges that organizations must navigate carefully. A primary hurdle is the heterogeneity of OT systems. Many industrial environments utilize legacy equipment from various vendors, often built with proprietary communication protocols and interfaces that were never designed for enterprise-wide connectivity. These systems can be decades old, lacking modern security security features and making direct integration with IT networks complex and risky. Simply connecting these systems to an IT network without proper safeguards can expose critical operational processes to new vulnerabilities that they were not designed to handle. Security is another major technical concern. IT security practices focused on confidentiality, integrity, and availability often need significant adaptation for the OT environment, where availability and safety are paramount. A security measure common in IT, like rebooting a system after a patch, could be catastrophic in an OT setting if it halts a critical manufacturing process or disables a safety system. Furthermore, many OT devices lack basic security capabilities such as encryption or strong authentication. Introducing connectivity without robust OT-aware security measures can create pathways for cyber attacks that could disrupt physical operations, leading to significant financial losses or safety incidents. Data management also poses a substantial challenge. OT systems can generate enormous volumes of high-velocity data from sensors and machines. Effectively collecting, transmitting, storing, processing, and analyzing this data requires robust IT infrastructure, including networking capacity, storage solutions, and advanced analytics platforms. Ensuring data quality, context, and timeliness is crucial for deriving meaningful insights. Issues such as data silos, incompatible data formats, and the sheer scale of industrial data must be addressed with well-thought-out data governance strategies and scalable technological solutions, often involving edge computing to process data closer to its source before sending it to centralized IT systems. To overcome these technical hurdles, organizations are adopting several strategies. The implementation of industrial gateways and middleware can help translate proprietary OT protocols into standard IT protocols. Network segmentation, creating demilitarized zones between IT and OT networks, and deploying industrial firewalls are crucial for enhancing security. Adopting open standards like OPC UA facilitates interoperability between diverse systems. Furthermore, investing in modern IT-OT platforms that offer edge computing capabilities, secure connectivity, and data analytics tailored for industrial use cases can significantly streamline the integration process. A phased approach, starting with pilot projects and gradually scaling up, is often the most effective way to manage the technical complexities involved. Section 7. Tangible gains. Real-world examples of convergence benefits. The convergence of IT and OT is not merely a theoretical exercise. It delivers tangible benefits that translate into improved efficiency, reduced costs, and enhanced operational performance across various industries. One prominent example is predictive maintenance. By integrating sensor data from OT systems on machinery with IT-based analytics platforms, companies can monitor equipment health in real time. Algorithms can detect subtle anomalies or patterns that indicate an impending failure. This allows maintenance to be scheduled proactively before a breakdown occurs, significantly reducing unplanned downtime, minimizing repair costs, and extending the lifespan of expensive industrial assets. A clear win for operational continuity. Improved energy management is another area where IT-OT convergence yields substantial cost savings. In manufacturing plants or large facilities, OT systems control energy-intensive equipment like motors, HVAC systems, and lighting. By integrating these systems with IT analytics, organizations can gain detailed insights into energy consumption patterns. This data allows them to identify wastage, optimize equipment scheduling to take advantage of lower energy tariffs, and implement energy-saving measures more effectively. For instance, a smart building can adjust heating and lighting based on occupancy data analyzed by a central management system. leading to significant reductions in energy bills and a smaller environmental footprint. Enhanced supply chain visibility and optimization represent another key benefit. When OT systems on the production floor are linked with IT systems managing inventory, logistics, and customer orders, a seamless flow of information is created. This allows for real-time tracking of raw materials, work in progress, and finished goods. Manufacturers can respond more quickly to changes in demand, adjust production schedules dynamically, reduce inventory holding costs, and improve on-time delivery rates. This level of integration transforms the supply chain from a series of disconnected steps into a highly coordinated and responsive ecosystem, directly impacting customer satisfaction and market competitiveness. Finally, quality control processes are significantly improved through IT-OT-IoT convergence. Sensors and vision systems on production lines can monitor product quality at every stage of manufacturing. This data, when fed into IT systems for analysis, can help identify the root causes of defects much faster. Operators can receive real-time alerts if quality parameters deviate, allowing for immediate corrective action. This proactive approach to quality management reduces scrap rates, rework, and warranty claims. The ability to trace product components and manufacturing conditions throughout the production process also aids in compliance with industry regulations and standards, further demonstrating the practical value of integrated systems. Section 8. Beyond the factory floor, broader strategic advantages. While improved efficiency and reduced downtime are immediate, compelling benefits of IT-OT convergence, the strategic advantages extend far beyond the factory floor, influencing broader business strategy and competitive positioning. One such advantage is the fostering of open standards and interoperability. As IT and OT systems increasingly communicate, there is a greater push towards adopting common communication protocols and data formats such as OPC-UA or MQTT. This shift away from proprietary closed systems reduces vendor lock-in, allows for greater flexibility in choosing best-of-breed technologies, and simplifies the integration of new equipment and software, ultimately lowering long-term system lifecycle costs. As IT and OT systems increasingly communicate, there is a greater push towards adopting common communication protocols and data formats such as OPC-UA or MQTT. This shift away from proprietary closed systems reduces vendor lock-in, allows for greater flexibility in choosing best-of-breed technologies, and simplifies the integration of new equipment and software, ultimately lowering long-term system lifecycle costs. Enhanced decision-making capabilities at all levels of the organization represent another profound strategic benefit. When operational data from OT systems is seamlessly integrated with business data from IT systems, executives gain a holistic, real-time view of the entire enterprise. This comprehensive insight allows for more informed strategic planning, better resource allocation, and quicker responses to market changes or competitive threats. For example, understanding the precise cost and efficiency of producing different product variants can inform pricing strategies, product portfolio management, and decisions about market expansion, thereby driving profitability and sustainable growth. IT-OT convergence is also a critical enabler for new business models and revenue streams, particularly those centered around services and data. Manufacturers of industrial equipment can leverage connected OT sensors to offer value-added services like remote monitoring, predictive maintenance subscriptions, or performance optimization consulting. This transition from selling products to selling outcomes or equipment as a service can create recurring revenue and deeper customer relationships. For instance, an engine manufacturer can sell power by the hour instead of just the engine, using converged IT-IoT data to guarantee uptime and performance, thus creating a stronger value proposition for their customers. Furthermore, a well-executed IT-OT convergence strategy significantly strengthens an organization's overall resilience and agility. The ability to monitor and control operations remotely, analyze performance data from anywhere, and quickly adapt processes to changing conditions becomes invaluable, especially during disruptions like supply chain interruptions or global crises. This heightened operational awareness and responsiveness facilitated by the tight integration of IT and OT allows businesses not only to weather storms more effectively, but also to seize emerging opportunities faster than less integrated competitors, solidifying their market leadership in an increasingly dynamic global environment. Section 9, the Converged Horizon, Future Outlook and Potential Developments. Looking ahead, the convergence of information technology and operational technology is set to deepen, driven by ongoing advancements in enabling technologies and an increasing recognition of its strategic importance. We can anticipate that artificial intelligence and machine learning will play an even more significant role. As more OT data becomes accessible through IT systems, AI and ML algorithms will become increasingly sophisticated in optimizing industrial processes. Predicting failures with greater accuracy, automating complex decision-making, and even enabling autonomous operations in factories and critical infrastructure. This will lead to unprecedented levels of efficiency, safety, and resource optimization in the coming years. The proliferation of edge computing will further shape the future of IT-OT convergence. Processing data closer to its source in the OT environment at the edge reduces latency, conserves network bandwidth, and enables faster responses for time-sensitive applications. Future edge devices will become more powerful, capable of running complex analytics and AI models locally. This decentralized intelligence, combined with centralized oversight and big-picture analysis via cloud-based IT platforms, will create a more balanced and robust architecture for converged systems. This distributed yet coordinated approach will be crucial for managing the vast amounts of data generated by an ever-increasing number of connected industrial devices. We will also likely see the continued evolution and adoption of digital twin technology. As IT-OT integration matures, organizations will be able to create highly accurate and dynamic virtual replicas of their physical assets, processes, and even entire supply chains. These digital twins will serve as invaluable tools for simulation, what-if scenario analysis, operator training, and remote commissioning of equipment. The ability to test changes and optimizations in a virtual environment before implementing them in the real world will significantly reduce risks and accelerate innovation cycles, allowing businesses to adapt and improve with greater speed and confidence than previously imaginable. Ultimately, the future of IT-OT convergence points towards truly smart, autonomous, and self-optimizing industrial environments. This will require ongoing collaboration between IT and OT professionals, continued investment in skills development, and a persistent focus on cybersecurity to protect these increasingly interconnected systems. The organizations that successfully navigate this convergence journey will not only achieve operational excellence, but also unlock new avenues for innovation and competitive advantage. The converged horizon promises a future where the physical and digital worlds are seamlessly intertwined, driving progress across all industrial sectors and reshaping the landscape of modern enterprise.